Welcome back for the next algorithm after the FCFS. That is the next one is the shortest job first algorithm. Right now, here the job that is a job timing or the which is required by the process for the execution. So we will compare here the job timing. The job time itself it is a burst time, right? So in this technique, the process having the minimum burst time at a particular instant of time will be executed first. So this is the algorithm how it works. It is a non-preemptive approach. So you remember the non-preemptive approach. What is it? That is, if the process starts its execution, then it will be fully executed, and then another process has given the chance, right? So if process enters into the CPU, then it will not leave the CPU till it will not completed its execution, right? So that is the non-preemptive approach. So we will start with the example. So just remember how the algorithm is working. That is a minimum burst time at a particular instant of time. That process will be selected first. So that algorithm we will apply here in this example. Again, drawing the Gantt chart to represent the algorithm, to represent the CPU scheduling algorithm. So we'll start drawing the Gantt chart for the SJF algorithm, right? So here the SJF, that is you can say job time, here burst time, that is a job time you can also say. So here we are having the four process P1, P2, P3 and P4 at a time, right? So here also you can say this burst time, you can also write down it as a job time, right? So we'll start drawing this Gantt chart. Okay, here starting with the first selection of the process. Now out of this, which process will be selected? So our algorithm is telling us that is the process which requires the minimum burst time, select that process first, right? So out of this four, minimum burst time is a 3 millisecond of the process P4. So the first process which will enter into the CPU at the 0 millisecond, that is a process P4. Okay, now this is a process P4 which enters into the CPU and it requires the 3 milliseconds. So it completes its execution up to the 3 millisecond. Okay, this is a preemptive approach, so no other process can enter into the CPU, right? If it comes next with a less job time, right? It is a non-preemptive, that's why, right? So this is a P4, it comes first. Next process that will be selected with the next less job timing, that's a process P1, right? We are having the process P1. It will enter into the CPU, right? Okay, it's not written properly. So here process P1 enters the required job timing for the process P1, that's a 6 millisecond. So here 6 plus 3, that's a 9. Next process that will be selected by your algorithm, that is a process P3 which requires the 7 millisecond, right? So here the P3 completing its 7 millisecond. So here the total time on Gantt chart, that's a 16. Okay, so here it's a 9 plus 7, that's a 16, and remain next process which remains, that's a process P2 which is the highest job timing. Okay, that's 8 millisecond. So here it is a 16 plus 8, that's a 24. Getting how to draw the Gantt chart? So this way we had completed all the processes by assigning the CPU to that processes. So that is a complete Gantt chart. Now next our task is to calculate the waiting time. So we will start with the calculating the waiting time for the each and every processes, right? So starting with the process P1, right? We will considering all the processes that arrives into the CPU at 0 millisecond, right? So the first response which is generated for the process P1, that is at the 3 millisecond, and it arrives into the SIP ready queue at the 0 millisecond. So there's a waiting time. What is the waiting time? That is how much time that process sit idle into the ready queue. How much time it has to wait into the ready queue for its turn for the execution. Getting? So that's the waiting time we have to calculate. So we have to just see how much time it is available into the ready queue. So P2, what is the waiting time? First response is generated at the 16 millisecond and it arrives at the 0 millisecond. So it is a 16 millisecond. So now I'm not writing the millisecond, just consider it. So next P3, first response is generated at 9 millisecond and it arrives at 0 millisecond. So it is a 9 millisecond, right? And the P4, which arrives at 0 millisecond, but the first response is also generated at 0 millisecond, so it is a 0 millisecond. Ready? So here now we will calculate the turnaround time also for each process. Process P1, turnaround time, that's a waiting time 3 millisecond plus the burst time 6 millisecond, it's a 9. Okay. P2 waiting time is a 16 millisecond for the P2 process and the burst time, that is a 8 millisecond, right? So it is a total 24 turnaround time. P3 turnaround time, that is a waiting time 9 plus its burst time, that is a 7, that is equal to 16. And P4, that is equal to, right now waiting time 0 millisecond and the burst time 3 millisecond, so it's a 3. So now average waiting time that is equal to 3 plus 16 plus 9 plus 0 divide by 4. Okay, so that is equal to, you can say, the total time 28 divided by 4, it's a 7 millisecond, right? So same way you can calculate the average turnaround time. Okay, so average of this you can easily calculate, that is average turnaround time, that is equal to 9 plus 24 plus 16 plus 3 divide by 4. So finally it is getting a 13 millisecond. Okay, so that is the way you can calculate the waiting time. Now here we have seen which algorithm, shortest job first. The job which is the shortest one, that will be selected first and it enters into the CPU. The next shortest job, that will be selected next, enters into the CPU. Next shortest job, this one P3 enters, and next P2 enters into the CPU. So this way we are selecting one of the process among the number of processes using the shortest job first algorithm. How to draw the Gantt chart? See here, that is 3 plus this 6, 9, like this way we are drawing the Gantt chart and calculating the waiting time and turnaround time. Okay, so that is a SJF example 1, that is we are completing. Here we are considered the arrival time, that is a 0 millisecond. We are assuming at 0 millisecond all these processes are available into the ready queue. Now next example we are going to see That is here. Look at this example. We are having the processes P1, P2, P3 and P4. Now here the arrival time is given. So whenever the arrival time is given, consider this arrival time. Okay, look at the arrival time and then apply the algorithm. So here the arrival time and these are the burst time. Okay, so you will start drawing the Gantt chart for the given example. Okay, so now next our aim is to select one of the process, right? Now which process we will select among this? Now we will start with at the 0 millisecond. Look at this processes at 0 millisecond. How many processes are into the ready queue? That is only P2, right? No processes are there. P1, P3 and P4 are coming at later on. So we will consider only P2, right? Whatever the bus time that is available with the P2, whether it is less or more with the next coming compared to the next coming processes, right? So here we will first enter compulsory P2 because at 0 millisecond no processes are available into the ready queue for the comparison, right? So here the P2 we will enter first. Now this is a non-preemptive approach getting. So as the P2 will enter into the Gantt chart or into the CPU, it will complete its execution, that is a 4 millisecond over. So after 4 millisecond we will see how many processes are arrived into the ready queue for the execution. So at the 4 millisecond P3 is there and the P1 which arrived at 3 millisecond. So right now into the ready queue two processes are there, P1 and P3. So we will apply the algorithm onto these two processes only, P1 and P3. So burst time or job time of P1 is 5 millisecond, job time of P3 is 2 millisecond. So out of these two, the less one is a 2 millisecond. So we will select the process P3 with the less job timing. It requires the 2 milliseconds. So 4 plus 2, that's a 6, right? So 4 plus 2 6 at the 6 millisecond. How many processes are into the ready queue? Now P2 is over, P3 is over. Now into the ready queue remaining processes are P1 and P4. Okay, so here we are looking at the arrival time. So one by one we are completing the process. P2 is already over. Okay, we will not consider this. P3 is already over. This will also not into the consideration. Now remaining process that is into the ready queue P1 and P4. So at 6 millisecond both are there. So we will compare these two process. Shortest job timing, that is of process P4. Okay. So here we will enter the P4, 6 plus 4, that is a 10, and next finally we will enter the process P1 which requires the 5, so it is a 15. So here the Gantt chart for the given processes. So how? This is the way the CPU will be allocated to the 4 processes which is right now available into the ready queue. So now next our objective is find out the waiting time, as you very well know about it. Okay, so waiting time. Okay, so for the process P1 waiting time we will calculate, right? So the process P1 first response is generated at the 10 millisecond. Here the response is at what time the process P1 is entered into the CPU, right? So this is the first time it enters into the CPU. That's a 10 millisecond, right? So here the 10 millisecond minus the arrival time of P1. Arrival time of P1, that's a 3 millisecond. So it's a 7 millisecond, right? Now the P2 first response is generated at the 0 millisecond, arrives at 0 millisecond, so it is a 0. P3 first response is generated at the 4 millisecond onto the Gantt chart, you can see, and it arrives at the 4 millisecond, so it is having the 0 millisecond waiting into the ready queue. and the P4 first response is generated at the 6 millisecond, and it arrives at the 5 millisecond, so it is equal to, it has to wait into the ready queue up to the 1 millisecond, right? So that is a waiting time for the individual process. Next we will calculate the turnaround time for the individual processes. P1 turnaround time, that is a waiting time 7 plus bus time 5, 12. For the P2 waiting time 0 plus burst time 4, that is equal to 4 millisecond. P3, that is having the waiting time 0 plus burst time requires 2 milliseconds, so it is a 2. And P4, it is having the waiting time 1 millisecond, burst time required the 4 minutes, so 5 millisecond. So you can see here we are having the waiting time for each and every process, turnaround time for the each and every process. Now you can easily calculate the average waiting time by making the summation of all this waiting time divide by 4. So finally we are getting it is a as 2 millisecond, and average waiting turnaround time, that is equal to summation of all these 4 turnaround time for processes divide by 4. So finally we are getting it is a 5.7 millisecond. Okay, so with this shortest job first algorithm, given the arrival time, right, and we had completed this algorithm example, right? So in next lecture we will see remaining algorithms after the SJF, that's the shortest job first. Okay, thank you.